perhaps it's interesting to show the circuit that I'm working on now. I want to make, say, a poor man's function generator with this chip CD74HCT4046, and it's here on the board here. And well, let me be more precise. It's here, this one. And I have already made another video about that chip, but I couldn't get it to a, say, higher frequency. And when you read a data sheet, it must be possible to get with this chip to, say, approximately 1.5 megahertz and perhaps even higher. Anyway, I could not succeed in getting it to 1.5 megahertz, but I could succeed to get it into approximately 1.2 megahertz. Well, I show it now in the development phase, absolutely not in the definite phase, and you can surely see that here. All is very sloppy, everything is hanging, all the components are hanging on the board, free hanging of a switch, etc, etc. But when we are talking about frequencies up to, say, 1.5 megahertz, this is a good way to develop a circuit. It's not typical high frequency. It's not typical VHF, so very high frequency. So it's a good way, say, to develop such a circuit. Anyway, what are the things that I'm doing? At first, we have the output of the chip, and as far as I know, it is on pin 2. Correct me if I'm wrong. And that pin 2 goes to a transistor amplifier, and it has everything to do with getting a circuit, an oscillator with a low impedance output. That's the most important thing, and it's absolutely not at the moment a definitive circuit, so keep that in mind. And I've used again a normal transistor, not a typical high frequency transistor anyway. My camera is blinking, that means that I have to stop. Thus, I want to show the first results in this way. Here we are on 1.2 megahertz. This is the waveform, and let me show the waveform on lower frequencies. There's always, say, here this kind of bubble. I hope to repair that. And now we're to the lowest frequencies, and well, we are now on 101 kilohertz. Well, let's go to lower frequencies, and here we meet, say, at the moment the issue. This bubble here, I want to remove it, and it's on 1.5 kilohertz. Anyway, lower frequencies. Here we are in the very low frequency band, 108 hertz. Also see this, and there is, say, a kind of way of setting the bias to such a, so here, and now I turn the bias of the first transistor, only transistor by the way, and it means that you can correct the waveform by biasing the transistor in a better way. And we are on 108 hertz. So perhaps I have to make, say, a separate potentiometer here, and that potentiometer must perhaps be moved to the front, and this is the front at the moment here. Perhaps it must be moved to the front, and also say this switch perhaps has to be moved to the front. And that's more or less all to tell about, say, the development of such a circuit. My camera still blinks, could be that it suddenly stops. Anyway, in that case, no problem. That's my ID at last. There's another kind of issue that has to be addressed, and that is how the potentiometer works. It's a poor man's circuit, so no very specific properties. But of course I want to make it in such a way that the potentiometer, the frequency potentiometer, works at its best. So anyway, that's what I wanted to tell. Thanks for watching. We are now on 1.2 megahertz with this waveform, and I've talked about the biasing, etc, etc. That was all to tell. Thanks for watching. I'm surely going to develop this circuit much better, but when you want to use it, it is still in a development phase, but it is already usable. And in the earlier video of this chip by the way, I did not pay enough attention to proper shielding, etc. Here's the front plate. The front plate has on its backside a layer of steel plate. Not steel, but tin plate. It is glued to it to give it a good shielding. And this is or will be the front plate in the future when this is all worked out. It can surely take 1 month or so till I can publish this circuit. Thanks for watching. Famous chip from Texas Instruments. And well, perhaps this is also usable when you, like me, like to do experiments.